power of x equals 81. Let's first take a close look at the left side of the equation. The expression 3 to the x appears 3 times, all added together. Now think about what it means to add something to itself. For example, what is 2 plus 2 plus 2? It's 6, which is the same as multiplying 2 by 3. You're adding 3 2's together, so it's 3 times 2. We can apply this same idea to our equation. Instead of adding 3 to the x 3 times, we can multiply it by 3. So the left side of our equation simplifies to 3 times 3 to the power of x. Now, let's rewrite the entire equation using this simplified left side. The equation becomes 3 times 3 to the power of x equals 81. Okay, we've successfully simplified the equation to this point. Now our objective is to isolate the variable x. We have 3 times 3 to the power of x equals 8. To get 3 to the x by itself on the left side, we need to undo the multiplication by 3. We do this by dividing both sides of the equation by 3. Let's divide both the left and right sides by 3. On the left side, the 3 in the numerator and the 3 in the denominator cancel out. This leaves us with just 3 to the power of x. Now, let's look at the right side. We need to calculate 81 divided by 3. 81 divided by 3 is 27. Excellent. We've simplified the equation to 3 to the power of x equals 27. We are very close to finding our solution. Our final step is to find x in the equation 3 to the power of x equals 27. We need to figure out what power we must raise 3 to in order to get 27. One way to do this is by finding a common base. Notice that both 3 and 27 are powers of 3. Let's list the powers of 3. 3 to the power of 1 is 3. 3 squared is 9, and 3 cubed is 27. We can see that 27 can be rewritten as 3 cubed. Let's substitute this back into our equation. Our equation becomes 3 to the power of x equals 3 cubed. Now we can use a very useful property of exponents. If two powers with the same base are equal, then their exponents must also be equal. In our equation, the bases are both 3. So, for the equation to hold true, the exponents x and 3 must be the same. This means that x must be equal to 3. This is our solution. We found a solution, but how can we be sure it's correct? Let's verify our answer by substituting x equals 3 back into the original equation. The original equation was 3 to the x plus 3 to the x plus 3 to the x equals 81. If x is 3, we have 3 cubed plus 3 cubed plus 3 cubed on the left side. We know that 3 cubed is 27, so the equation becomes 27 plus 27 plus 27 equals 82. Let's do the addition on the left side. 27 plus 27 is 54, and 54 plus 27 is indeed 81. We get 81 equals 81, which is a true statement. This confirms that our solution, x equals 3, is correct. To recap, we solved this problem in 3 steps. First, we simplified the left side by treating the repeated addition as multiplication. Second, we isolated the exponential term by dividing both sides. Finally, we wrote both sides with a common base and equated the exponents. We then verified our answer. Thank you for watching.